Welcome back to section 9.2 Pre-Calculus. We're going to talk about graphing polar curves. Now, we graphed some last week or in the earlier videos if you watch those. Um, and we just did basic ones like circles. We didn't get into Limasans or roses or lemniscates or spirals of Archimedes. In a typical year, we would do an activity that's like a 2-day activity, and you'd go and you'd explore all these beautiful graphs, but seeing as how we're online and I'm limited to 30 minutes, we're not going to have time to do all of that. So instead, I'm going to present it to you in this graphic organizer, and you're going to learn the rules about them, but you're not going to be able to discover them for yourself. We talked about basic circles before. So we have two types of basic circles, when r is equal to a cosine theta and when r is equal to a sine theta. Now, if it's cosine theta, like this one here or this one here, notice those circles are symmetrical about what we think of in our heads, because we're so used to rectangular coordinates, as the x-axis, but that's really the theta is equal to 0 axis, or we call that the polar axis. So they're symmetrical about the polar axis, and if it's a is bigger than 0, we're to the right of the pole. Remember, your pole is right here. And if a is less than 0, then we're to the left of the pole. Whereas if it's sine theta, then we're now symmetric about our quote unquote y-axis, which is really the theta is equal to pi over 2 axis. And if it's positive, we're above the pole. Negative, we're below the pole. All right, so that's one of the most basic um, polar graphs. The next column are called Limasans. Limasans. I've heard of them called Limacons too, but or Limasans. I think it's Limasans. Um, so we have four different types of Limasans. The first one, and you guys were trying to name these last week, so they should look somewhat familiar to you. The first one is where we've got a circle-ish kind of thing with an inner loop. So it is actually graphed this way. So notice how it went all the way around and then it makes that inner loop. A cardioid, that's the one that I think some of you called a peach, or a heart with cholesterol, I think was another favorite. And it makes kind of that pointy um, dip to it right there. We have a dimpled limason, and it's got a dent inside, but it's not pointy. It's kind of flattened out there. And then a convex limason is kind of like a flat tire. It's not extremely flat, but it's flat. It doesn't make a full circle. And the way you can tell these guys, it's always if you have a plus or minus b cosine squared or a plus or minus b sine squared. And so it all comes down to, first of all, if it's cosine squared, again, you're going to be symmetrical about the polar axis. Oh, I've lost my mouse, so just bear with me. And so this first one here would be like a cosine one. The second one, since we're symmetrical about the theta is equal to pi over 2 axis, this one would be the cardioid. Here is an example of a sine. The dimpled limason would be an example of a cosine because it's symmetrical about the polar axis. And this convex limason would be an example of a theta over 2, so a sine. And it comes down to the A and the B. So if the A over B, that ratio between the two is less than 1, you've got that inner loop. If it's equal to 1, you've got a cardioid. If it's a dimpled limason, it's going to be somewhere between 1 and 2. So some fraction between 1 and 2. Think like 3/2 or 7/6 or something like that. And then a convex limason, you've got A over B is greater than or equal to 2. So I have lost all connectivity with this sheet. Well, this seems to work, but I can't seem to write on it. It's the writing part that's not working. So I'm going to go ahead and pause the video. I'll make another quick video about roses and lemniscates and spirals of Archimedes, and then we'll get to graphing some of these.